Such a full 2 days. It's been amazing, and I think it's a testament to the hard work that's put in by Virtus Lab and the team here that we have such a great conference this year and in previous years, and it's getting better and better. So I'm being told to move backwards. Yeah. Am I going to fall off the back of the stage? Yeah. Is that okay? Is this for the video? Can I hide behind my own computer screen? Like any other stage directions? No. Okay. So we have in front of you a panel of 5 Scala experts, all involved in some way in tooling. I'm going to introduce them one by one, and I'm going to start with this far end, Shane Delmore, who has come over here from California. Could you give Shane a warm welcome, please? It's his first time on a panel, is that right? And he's a little bit nervous. Yes. So please be nice to him. And Shane, I think, is one of the most enthusiastic people I know in a community that has many enthusiastic people. And I mentioned this morning, if you came to my keynote, I'm sure you all did, that we had an LSP and Scala tooling protocols working group meeting yesterday evening. And in that meeting, we co-opted Shane onto the group. So Shane is now a member of the LSP working group. And can I just start by asking what is exciting for you about these working groups and the prospects for Scala going forward?
Yeah, it's been a really great year, I think, for Scala tooling. I work on the Advanced Scala Tools team in Twitter, and we're always trying to help our engineers be more effective. And I really believe strongly one of the ways you help them be more effective is meet them where they are. And so LSP particularly, but also the BSP protocols are really interesting because if we have a user who loves working on Emacs, or I think 60% of our users are IntelliJ, but that also means 40% are not. So the idea to have good integrations, especially handling a code base our size, and whatever editor you're comfortable working with when you come to Twitter is pretty exciting.
Are you allowed to say what the size is, roughly? I mean, it's big. It's big, but not, yeah, like as big as you can imagine, okay?
And then the code generation runs.
Oh yeah, so as big as you can imagine, and then bigger. That is Twitter's code base. Cool, thanks, Shane. And to Shane's right is Mikhail Mutyanko. I hope I'm saying your name correctly. Welcome. Would you please give Mikhail a warm welcome? Mikhail is a developer on IntelliJ at JetBrains.
Yep.
And I've heard rumors JetBrains might be working on a competitor language to Scala. I don't know if you can confirm those rumors.
Kotlin by any chance?
I'm not going to comment, but does JetBrains have plans to, I don't know, drop Scala support in favor of Kotlin?
In a way, I've been expecting such question. Yeah.
Yeah.
Obviously.
Okay, you heard it here first.
To say it short, no. Kotlin is not really a competitor to Scala in general terms, since they have pretty much they have their own niches, and some things you can write in Kotlin, and Scala would not be very appropriate for that. Like, for example, you would probably choose Kotlin for Android rather than Scala. But in other way, we are definitely not replacing Kotlin with Scala or vice versa. Even considering that parts of IntelliJ are written in Kotlin and not in Scala.
Right.
So the short answer is no.
So if Scala and Kotlin are
Not really competitors.
Not really competitors, to harmoniously coexist way into the future. What is the situation with compatibility between them? Can you call Kotlin from Scala or the reverse, or what's the story there at the moment?
Currently, I don't think we can cross-compile Scala and Kotlin because in this situation with, for example, Scala and Java, the compiler needs to be aware of, each other's languages. And if we have 3 languages, then things are getting more complex, and we need to force, Scala C team to be aware of Kotlin, which I'm not sure is going to happen, honestly. So basically, the only way is to build separate modules.
Okay, but they could coexist in
terms of
some sense.
The underlying platform being the JVM, and they can interop via Java.
Okay.
So
maybe we can talk about this some more at ScalaSphere next year. Okay, so to Michael's right is Olafur Gerson. How did I do?
Great.
Okay, I'm getting better. Like, to most people, he's Olaf, but I always like to put the effort in to try my Icelandic. Olaf is a developer at the Scala Center. So please give him a round of applause. And you are known for having worked on Scala format,
Yep.
Scala meta,
Yep.
semantic DB. Have I forgotten anything?
Scala fix.
Scala
Fix.
fix, of course. Scala fix. I thought you said Scala blitz then. That wasn't you.
No.
And more recently, the BSP specification.
Yeah, I collaborated with Jorge to write up the document.
Okay. So, what do you think about the...
And also Guillaume on the other side there. He was
Yes,
also...
well, we'll come to Guillaume in a minute. You can come closer, Guillaume. I was shifted to my left, and then Piotr can come as well. Let's all get a bit cozy up here. So, and now we're going to be told to move somewhere. What do you think of the current explosion of build tools for Scala?
I was hoping not to get this question.
What does it mean for BSP?
I think it's just very exciting to see a lot of movement in this area. I think there is frustration with some existing solutions, and I think they're being addressed. And I think to really end up with something much better, I think you need exploration. You don't reach the final solution right away. So when I hear people complain saying, "Oh, tool fatigue, too many build tools," I'm thinking we haven't really reached the place where I'm super happy with everything that exists. So I think exploration is fair.
Yeah, and experimentation. And I think people, a lot of people are happy with the situation. They don't want to change, but I guess there are compromises. Mike? If you're going to say something,
Yeah.
Like you can mutter with it over there.
No, I don't know, but yeah, I'm happy to see exploration in the area.
Yeah.
Yeah.
Cool. I will open the floor to questions shortly, but we are next going to be introduced. Oh, no, this mic stays this side, and
Is it on?
yeah,
Yes.
you're live. So to my right is Guillaume Mart.
Yes.
Who is actually you're at EPFL. You're working with Martin Odersky on the .E compiler. What's your exact role?
I fix stuff. I'm a PhD student. And I work on various things on the .E compiler, like the type checker, the tasty interchange format, interactive support of all things. Sometimes I write the SBT build, that kind of things.
Okay. And how do you find working with Martin?
It's great.
Nothing more to say.
Like he always comes up with new stuff. We always have interesting discussions, and he's so productive. Like he's probably the most productive programmer I know.
I would actually say that's one of the most overlooked aspects of the output of the Scala community. That Martin, as well as being a professor at university and teaching students, he does come up with many new ideas. He publishes papers and still answers my emails within about a day. And I can't keep up with him. So I would personally second that, and I think it's very much overlooked. So I'm glad you mentioned it. And if you want to add something, or if not, did we give Guillaume a warm welcome? We didn't. I forgot. I'm sorry. And then we're going to pause, and then we're going to clap again to welcome Piotr.
Hi.
So Piotr is a developer at Virtus Lab, and let me see what question I was going to ask you. I don't know if I had a difficult one here.
Hopefully not.
No. Well, I was going to mention that the first time we met was about 4 years ago when I was working on a distributed system, and I was completely stumped by a problem for several weeks, and I asked Virtus to help out, and Piotr drew the short straw and fixed my issue in Akka within a week or so. So I was super impressed by that. But what are you doing now at Virtus, and what is Virtus doing?
So right now we are, well, actually for a few years already, we are trying to fix problems of developers who are not really so technical when going to Scala. It's mostly like business analytics and guys who are writing business code. So they are not so keen when it's going to the details of the tooling. They just want to be productive. So we are trying to do all the stuff around that to help them be productive and to make the tooling really work for them. So all the quirks of the tooling, we are just trying to hide them or fix them if we can, and just provide them seamless experience, as seamless as possible with the current tooling. So it's going from many different directions, basically just to make it easy for everyone.
Okay, I noticed you said hide the quirks there. Sweep them under the rug so nobody notices. Is that in terms of working with a language which has many quirks and we're often stuck with them? Is that the best we can do you think, in many cases?
So
it was a very abstract question,
yeah.
without any particular quirks in mind, but it does seem like sometimes we can aspire to completely solving a problem. Other times we have to work with what we've got, and it's intractable to solve the problem.
Right. So I would say it depends. So there were problems which we tried hard to solve, and we weren't able to solve them completely. Like, for example, we were stumbling with Scala ID for probably like few years. And while we solved a lot of problems, like for example, we did the expression evaluator to make it easier to work with debugger and so on, we still weren't able to solve some fundamental problems, like Scala ID from time to time was crashing completely, corrupting all the caches, and you weren't able to get back to work unless you wipe out everything completely from the hard drive.
That sounds like quite a quirk.
So we actually had the tooling to do this wipeout for the users because it was so often that otherwise we wouldn't be able to do anything, just writing to the emails what they need to do to make it work again. But so that are things which you sometimes, well, maybe you can solve them, but you would need to change full platform, and sometimes it's not obvious what you need to, what is really the problem. Problem is somewhere inside the architecture, but it's sometimes just cheaper to, for example, in this case, we just migrate to IntelliJ, and it was from the perspective of time, it was a really good decision. And sometimes there are problems which we can fix, for example, like with compilation speed, we are trying to use something which is actually existing currently. So rather than, for example, based only on IntelliJ compiler, we plug in newer Zinc use case from the servers, just trying to build incrementally.
So Zinc is the incremental compiler part of
because
SBT.
previously we were trying to build some caches for the particular commit, but if you don't hit the exact commit, it doesn't make sense in case of normal compiler. With Zinc we can build for some checkpoints and then just based on the Git hash, just find the closest one and then try to build incrementally inside the ID, for example. So you can use existing things sometimes to build something which provides value. Well, sometimes you need to switch stack or wipe up something completely because it just doesn't work.
So it sounds very much like the donkey work of the of the Scala ecosystem that you're doing there. Okay, so I will ask the audience if you have any questions. If you raise your hand, there is a microphone which will go around. Any thoughts on any talks you've seen that the panel may have opinions on? I'm after controversy. Yeah, here, okay, if possible.
I have one remark. Maybe it's not a strict question. That SBT is being. We complain about SBT on this conference a lot, but do you think it's really fair? I think there are many successful projects using SBT, and I don't really see anything adopted on a big scale and any alternative, and I don't really know if it's fair for a SBT team to, hear all these things.
So the SBT team, I think, have left. So it's a shame they didn't get to hear that support. Olaf, would you like to say something about this?
So, I mean, I think I'm very productive with SBT myself. I've tried other build tools and I've felt myself a bit paralyzed because I'm able to usually get what I want done in SBT. So I share your sort of feeling. So I think a lot of the experimentation that is happening is not sort of anti-SBT either. Like, for example, Bloop is very complementary with SBT. People have built large amount, like big projects and pipelines for their CI, for publishing, and local workflows that already work with SBT. But the pain points are, for example, that if you just do Control-C, you're suddenly spending the next 30 seconds heating up the JVM for compilation. But yeah, I share your, but not all of the effort that are ongoing are sort of saying, I don't say that the vibe is SBT is bad. That's not my impression, at least.
And I would actually add that even though some of us are working on other alternative build tools, we're all having interesting, productive conversations with the SBT team. They're not only cooperative, but they go beyond and they actively accommodate other ideas, and they have the same. I think they have the same goals as us in terms of us being people who are thinking about alternatives. They care about the same things in programming.
But I will say though, I've spent almost 2 years doing quite a significant amount of SBT plugins, and I cannot sort of expect anyone to invest the same amount of time in learning SBT as I have. And I am a bit concerned that people are thrown sort of too quickly into the deep water to get productive with just running an application or pushing a jar into a server via SBT. And I really deeply care that workflow should become much easier for beginners.
So how would you describe the learning curve? Because it is quite easy to get started with. From my point of view, and I've done it a couple of times, it's quite easy to get started with a simple SBT project. I just copy-paste the previous one which succeeded and change the project name. But as soon as I need to do anything a little bit more complicated than that, I fall over and I fail, and I have a very strong reluctance to investigate the documentation and find out what I'm doing wrong, because it's let me down in the past. No, not anymore. It went out into the audience. So, yeah, Guillaume, what are your feelings? You have also worked with plugins with SBT, so you've got good experience.
No.
Wait, okay, sorry. When I say good experience, you have much experience.
I have some experience. Like I've tried to limit how much, like I have to depend on, let's say, SBT internals. I've worked a lot with incremental compilation in SBT to make it work with Dotty, but that work is now actually useful with other build tools thanks to the modularization of SBT incremental compilation into Zinc in SBT1.
And that's the work of the SBT team at Lightbend.
Yes. So
And
I'm very thankful for that.
yeah, and I think we shouldn't forget that Lightbend is paying 2 full-time developers to work on SBT, which is very much a gift to the community, which I think we should be sometimes more appreciative of. I don't think they're full-time. Well, they're not here to defend themselves from you, Olaf. But no, I think they do other things. But they're employed full-time by Lightbend, and they do spend some significant part of their time on SBT. Does anyone else on the panel have comments on SBT in particular? Yeah, Jorge, if you want to add something, because you are, I would say, an SBT expert.
So myself, I like SBT a lot. I love it, and I love it so much that I hate it a lot as well. So I hate it when it doesn't do what I think it should do, or when there are some architectural problems that cannot be addressed easily. So I echo Olaf's comments before. I don't think that we are here to thrash SBT. In fact, I very much love it, and I try to contribute as much as I can upstream. But in all of these years of experience have taught me that I think it's good that we experiment with other solutions, and I don't see SBT addressing all my problems in the next 2 years. So I prefer to bet on other solutions right now.
Would you say that the evidence, or there is some evidence for that, in that ecosystems like Rust have cargo, which I don't know much about it, but I only ever hear positive things about it. And should we be rightly jealous of other ecosystems?
One thing I've observed, at least, I think it's fairly specific for the Scala community, but people push really hard their build tools. As in, everyone wants to do formatting on compile. I don't think Cargo supports that out of the box. But it seems like you can't even have a build tool in Scala today unless people will ask for that feature within the first day.
I'm not going to give it to them. Okay, do we have any more questions? Yeah, Zizek.
I think I can go like the 2 comments about the SBT thing first.
Yeah, so we'll hear the comments on SBT, and then we'll maybe move on
then I
to
got
other.
a question
Then,
also.
yeah, sure.
Yeah, so the comment about SBT is that I was talking about like guys that he was like Python big data developer, and then started learning Scala, and he told me something like that. I wish there is an SBT for Python. Yeah. So I think we sometimes have to appreciate how much SBT gives.
Yeah.
And just to close the question, that because it was like there is no other tools, build tools that are running on the production. I think it's not fair. Plants and base are running on the production. And just to be precise, there is also Gradle that compiles a lot of Scala code.
Yeah.
Whenever we want to or not.
Would you pass the microphone backwards towards Jamie behind you? Sure. Please. Go for it, Jamie.
One thing that I think is really great about the criticism of SBT is that everybody criticizes the tool and not the people involved with it, which is really good. One of the things that makes me nervous is that we lost Mark Hara, and Josh, for other reasons, ended up leaving as well. So we can't lose Eugene, we can't lose Dale, we can't lose Tony. These are people who are doing wonderful things for us, so continue to do that, please.
Yeah, I fully support that. And I think the reason is that they are the generous people that they are, and give their time to helping people with a tool that isn't that easy to learn. So, yeah, attack the tool, not the man. So, Stu.
I have a question. So I know 2 of the responses on the panel, so I'm kind of interested in hearing from a lot of folks, but do the people on the panel think that source dependencies are an important way to improve the ecosystem, or are the most important way to like improve the velocity of the ecosystem? Or do you have something else in mind that would help improve the velocity and health of the ecosystem?
So we'll start with
from everyone.
So we'll start with Stu's good friend and colleague Shane at the end.
I think Sebastian did a good job of discussing the pros and cons of that, which I really appreciated. But you know, as engineers, we're always making trade-offs. Now we have to decide what the trade-off is. And it was his talk was really interesting to me because he laid out the facts, and I think was hoping that hearing those facts, I would agree binary compatibility is the way to go. But I actually went the opposite way. After hearing that, I feel even more strongly source compatibility is the way to go, because we have tools to at least evolve source. We don't have great tools to evolve binary incompatible things, but the biggest one, as he mentioned, is that if everything goes perfect, you could achieve perfection with compatibility if nobody makes a mistake. If we don't use traits, if we don't use case classes, never add a default, that's a lot to ask. Anytime you're asking for uptime in a system, if your system is reliable as long as nobody makes a mistake, I think you need to keep looking at options. And whereas we can't guarantee perfection with source dependencies, but the worst case scenario is not nearly as bad. So maybe we'll have more stubbing our foot, less breaking our leg.
Good analogy. Mikhail.
So I'm gonna mostly agree on the previous approach, but as to me, I think that just proposing the question itself as source dependencies as the ultimate solution to a problem is to all the problems is incorrect. Like there are too many scenarios too many different scenarios that we usually run into, and so far it's an experiment, and as an experiment we must gather more data.
So do you think it's the devil we know versus the devil we don't?
Yeah, basically that's it. If not that, what else could we do?
So if source dependencies aren't the solution, then what else might be?
Like trying to improve on the binary dependencies. Like we had a talk about not breaking the compatibility. Perhaps if that's the critical pain point, then you can investigate. And probably you can afford to investigate both scenarios with the source dependencies and not breaking binary compatibility. So that's...
yeah, Shane, and then we can swing the mic back this way.
Yeah, I guess one more point on that was that the approach offered on binary compatibility, I like that there was an approach offered. It was talking about, say, Spark. Maybe at Scala major versions we bump our APIs. But what was said there was that now we maintain two sets of code, and we have seen that's an expense people don't want to spend. Speaking of the success story, we mentioned Scala.js, 3 years of binary compatibility, only beaten out by SBT 13. And from plugin authors' point of view, SBT 13 was quite a pain. Was that people were begging for a 14 release so we could have a 2.12, 2.11 or 2.12. And I think if a fair response from people on the SBT team was, we're giving everything we have. We don't have time to maintain 2 versions. Now we're telling the Spark team, hey, can you maintain 2 different versions? That's not free. I don't know that we have time, especially in a community where many of us are volunteering, to say all you need to do is maintain 2 versions for a while.
Is it just 2? Is it potentially many? Yeah. Olaf.
So to answer
go for
the question, I think there are 2 different scenarios. One is sort of the closed world. If you have a company, you're at the end of the world, and I think source dependencies work really great here because you can just build your full source tree and you know that you're not going to have surprising breaking changes downstream because there is nothing downstream. In the open world, sort of for library maintainers, source dependencies don't really work. I don't think so, at least for the ecosystem. We have way better tooling to detect binary incompatibilities. As a library author, we have fantastic tooling like Mima, that enables you to just say, hey, you have broken binary compatibility with a previous release. Whereas for source compatibility, we have no tooling to tell you like, hey, you just added this thing here, and this is, and essentially almost any change you do in sources is source breaking, almost, because you might be shadowing something, etc., from a wildcard import.
So Stu's mentioned the community build.
Sure, yeah, but that's still very small subset of the ecosystem.
It's opt-in.
Because you essentially have all of the code bases that are proprietary that are also part of the source. To increase velocity for the ecosystem, I'd say that what I would like to see more focus on is the ease of publishing. It's way too hard to publish today.
And slow?
I'm sorry?
And slow to publish?
It's not that bad, but like as a project maintainer, that it should be way easier to have push, like release to Maven on Git tag push, which I find really great. So, okay.
Thank you. Guillaume, I'm going to ask you specifically about Tasty and where Tasty might fit into the binary source compatibility issue.
From the perspective of a compiler developer, so binary dependencies are not great because if you change some of the details of how you implement certain features of a language into JVM bytecode, that's going to break your ecosystem. But source dependencies are way worse because if you change, say, any details of how type inference works, that's going to potentially break any number of projects. So what we've been trying to do in Dotty is have this new format we call Tasty for typed abstract syntax trees, which is part of the class files, or they could also potentially be separate files next to the class files. We haven't decided yet. And the Tasty trees are basically what the compiler outputs after type checking your code, but before doing all the transformations that eventually gives you JVM or JavaScript code at the end. And the advantage of doing that is that if we make change in the compiler that happen before type checking, you can still depend on some artifact which was published with an ancient version of a compiler because it's already type checked. So we're not going to redo implicit resolution, we're not going to redo result type inference, that kind of things. And you still have issues with, well, what happens if some project changes their method signatures? Now you need to change your code again, that kind of things. But I think it might be possible to develop tooling or even make it part of a compiler on top of Tasty to do things like automatically fixing your code based on, say, I'm a library author, I make a breaking change to add a new parameter to one of my methods with a default value. I can then write some kind of static description of this change so that existing code that uses the old method can be on the fly changed to use the new method, because the existing code would be in some Tasty tree somewhere, and when I actually compile all of this down to bytecode, I read both the Tasty tree and the description of how I should actually compile this code with this new version of a library that someone has published.
Okay, thank you.
So we'll see.
So Tasty could be a happier future.
Yeah, but that will depend on, like, basically we need build tools to experiment with these kind of things.
So more experimentation is very much the what we need to do. Piotr.
If I could say one thing about experimentation, actually, not maybe only on this topic, but generally, I think this is something which you also seen very much on this conference, that in the Scala ecosystem, we start to seeing more tools which are smaller, like, for example, presentation about semantic DB today. I think it was 13,000 lines of code plus some protobuf stuff. So it's really small comparing to some big Scala projects, right? But it's also easy to plug into many different existing solutions. And I think that kind of modularization, which we are starting to see, and splitting into smaller tools, very similar to what we see, for example, in Unix versus like Windows ecosystem, right? You have very small tools which do one job but do it good, and it's easy to reason about these small tools. It's easy to keep mental model of them, and it's easy to also probably change them, because if code base is small, and the function which this tool is doing is very good, very specified, very nice way, then it's very easy also to come to the community and start working on that. And maybe if you have like 5, 6 of these tools working together, then it's also easy to plug something in the middle, like whatever, if it's build tool or something else. But you can try to experiment more just by changing the way how these tools working with one another. Maybe plugging something in the middle. But if it's something monolithic, like it's for example ScalaSphere, then it's almost impossible to someone from the outside to come and do something. There is just a handful of people who really could do something about that.
So the key is composability, would you say?
Yeah,
exactly.
Does anyone else have any thoughts on the current state of...
Somehow I was given a microphone.
Oh no!
So it appeared in my hand. I didn't even ask for it. I agree with a lot of points that were made by the panel. I would like to stress one of Olaf's points, which is that we do have really good tooling to check binary compatibility and not to make any mistake. Like we actually can publish.
But people still make mistake.
Huh?
But people still make mistake. Like you gave the example of a ScalaSphere team.
Yes. So if you do go against the tool and filter out some stuff, then you have to be really careful, and you have to know what you're doing. But as long as you don't have any filtering out rules, then the tool is actually giving you perfect information, basically. I mean, modular bugs, but it doesn't have many bugs. I haven't encountered any significant ones. So that's one thing, and really for source compatibility, we really don't have any kind of tool. It's actually quite distressing. But it also joins. So another thing I would like to say is with respect to Tasty. So we have sources, we have binaries, and then we have Tasty. Sources, as I have tried to explain in my talk, is basically the worst of all the possible worlds. As far as providing perfect compatibility is concerned, with sources you cannot do anything, basically. You will always break some amount of stuff. With binary compatibility, it's possible to provide 100% thing, but it has to be quite, I mean, you have to do some significant effort to get to that point. You can use tools to help you, but you have to learn the way to really leverage the way you design your libraries so that you can evolve them. I think maybe Tasty has a little bit of the best of both of those worlds. It is definitely stronger than source dependencies. So it leans more towards the binaries, in the sense that we have something that is already type checked, already resolved, implicits have been done, imports have been dealt with. So there is no problem with things like shadowing and type inference, as Guillaume mentioned, and stuff like this to come in the way. And at the same time, it does not bake too many details of how it's going to be compiled yet. So I think Tasty might actually provide us with a path forward to enable more changes in a library that would not break compatibility. However, we will definitely need a tool like MIMA for Tasty, something that will check Tasty compatibility, that you publish a new version of your library and the tool will tell you, yeah, it's okay. Anything that compiles against your Tasty is going to still link and behave the same. Or on the contrary, oh, here you I don't know, you remove the methods or you did something that even with tasty, the compiler is not going to save you.
So, Sebastian, if you just hold on to the mic a moment, should you also make an important distinction between the point at which you discover the incompatibility? With source compatibility, you discover at compile time, no damage is done, whereas with binary compatibility, you might not discover until runtime, which can often lead to worse problems. Is that a fair point to make? Like one seems worse than the other.
I'm not sure I got the distinction. Come again?
The distinction is that you can't run sources. You have to compile them. So that is the point at which you discover there's a problem, where everything is quite safe. With binaries, the problem may be when you construct a class path where things don't link, and that is something you discover when a certain method maybe gets run sometime many minutes into a production.
Right. So I think so probably we can definitely solve this problem if we have if we actually have a linking step.
Yeah.
So on the JVM, the linking step happens at runtime and lazily, which is why we get runtime errors for linking. But if you're really concerned about that kind of stuff, it's really easy to actually build a tool that will do a check at link time that that specific class path is never going to throw a linkage error. It's actually so easy that Scala.js and Scala Native do it as part of their normal compilation step. They immediately tell you, oh, this method here through your binaries, it's not available. So they actually refuse to link in this specific case. And we could definitely build a similar tool on it. Maybe ProGuard actually does that.
Doesn't JLink does that too? Because JLink built into Java 9 and more, and I think it does that. I don't know.
I just wanted to emphasize it, like what Guillaume has just said. I think JLink is solving that problem now for Java 9. So maybe we could enrich JLink with Scala-specific analysis so that we can deal with that problem.
Okay. Thanks for the addition, Jorge. By the way, does anyone know how we're doing for time? We can keep going, Natalia? Yes. Yeah, okay. How much longer? 10 minutes, okay. So any more questions? Sorry? 15, okay. Yeah.
Okay, I have completely different question. There's one thing
course.
which is especially interesting to me, but it wasn't mentioned during this conference.
Speak a little louder.
Because Eugene Burmaka did not manage to be here. But we have two people from Twitter. So what's the state of reasonable Scala compiler? What's the goal of it?
So I think...
Yeah, what's the state of reasonable Scala compiler?
I
think Shane has a quick answer on this.
The state is top secret. Eugene's been doing a ton of great work on that, and I don't want to steal his thunder. He's planning on doing a conference talk at Scala Days, and where he's going to show off all the awesome things he's been doing. And so, yeah, I want you to watch that.
I think you just gave away that it's going to be awesome. There was a big reveal there that you didn't. It slipped out.
It's going to be awesome.
It's the first and last time Shane is on a panel. Any more questions? Put your hand up. Yep.
I got quick question to everyone on the panel.
Are you moving around the different seats?
Yes, I can move you on the
It's like, will you pop up over there with a question next?
And now I'm here.
Okay,
so there is a quick question to everyone on the panel. So we really wait for a breakthrough in the Scala tooling system, and this is the compilation speed. So my question is, because I know that there will be a breakthrough. So which compiler will be like this one? Will be like the fastest? The ScalaC, Dotty, or I don't know, Kentucky Mule or RSC, or maybe Lee Hanoi decides that over the weekend he needs a faster compiler and create one. So that's my question. But I really would like everyone would say his mind, because there is I know that Shane might say about RSC, and I'm curious what you guys thinking about that.
So I think Shane can't easily talk about RSC because it's
Yeah, I don't have to talk
top
about
secret.
RSC, but I mean, I do think we know, whether it's the work going on with RSC, with Kentucky Mule, with Hydra. I mean, our cores aren't getting faster; we're getting more of them. So we definitely have to crack the typing in parallel problem. Yeah, we have to go that way. But regardless of the longer future, I'm going to have a laptop with 20 cores. I sure hope it doesn't just burn one type checking. There's also delivering the features we have now. I think we have a large portion of our community that's stuck on 2.11, and I believe someone said between 2.12 and 2.12.5 we had a 20% compilation performance improvement.
20.
So I want to get people the speed ups we have now, but also we need to have some parallelism.
Yeah, I would concur on the topic of parallelism because we have, at IntelliJ, we have experience of using Hydra, and the speed ups are quite reasonable for, for the project that is not insanely large, but large enough. Yeah, I think we've been at a talk given by Martin at the previous Scala World about
2016
speeding up the compiler. Yeah, and
is it Scala? I don't remember what Martin said at Scala World.
You said 20% during 2 years.
I believe Julian's talk, he was showing the numbers between 2.12 and 2.12.5. There was work on speeding up the class path, and there's a bunch of work that some companies have donated on the back end to the back end generation. But I think, if I recall, most of Martin's talk was about possible things in the future with Dotty and Fusion. I'd love to know if Guillaume could talk to that. I haven't seen any results from that.
Guillaume?
All right. Anyway, I would say that we're mostly counting on parallelism as well and improving the existing solutions because, not many projects. Some of the projects are not really easy to migrate to tools like reasonable Scala compiler at the current state.
So parallelism, we're going to go to Guillaume in a second, but parallelism has sort of two angles. One is the microscopic and one the macroscopic. You can often divide a project up into modules which can be compiled separately, but someone mentioned, Shane I think mentioned, type checking in parallel, which is very much more fine-grained. If anyone has any thoughts on which of those is most likely to bias the bigger speed-ups with the least effort, feel free to comment.
Yeah, certainly I don't think type checking in parallel is least effort. But it's definitely something we want to explore in Dotty. Just parallelizing. If everything after type checking should be easier. Parallelizing type checking, you have to be more careful about. Like you have to introduce locks in some places, and you have to hope that that doesn't means everything gets stuck doing one thing. So it's something we want to explore, but haven't spent much time working on. But compilation speed can also be improved by things like making sure that you're always using a hot compiler, because when you start SBT and you do one compilation run, and when you redo, you redo compilation run, you do that a few times. So by the time the JVM has had time to JIT compile everything it wanted to JIT compile, you get more than a 2 times improvement.
Well, I think if anyone came to the Bloop,
yes, exactly. So
Bloop talk earlier, I think the example that Martin gave was coming down from about 10 seconds for a cold compile to 2.7 seconds, or was it 1.7 seconds? 8 to 2, so it's like a 4x, give or take. That's my experience as well when I've tried this.
So anything we can do to make sure we're always using a hot compiler helps. So Bloop is an interesting way to do things because it just has this one job of keeping the compiler hot, and you just ask it to compile your stuff. But yeah, I think we can even maybe do better than this because even with Bloop, we're still recreating a new compiler instance every time. So we are every time you're redoing your compilation, you still have to look up the symbols in all of your standard library. because all of that is information we only load at runtime, and we don't share between different compiler instances. But say when you're in the REPL or in your IDE, we don't do that. We keep using the same compiler instance. And if we could do that for full compilation, we'd have like a big speed improvement too. But it's tricky because basically you don't want to keep old information that is now obsolete. So you need to do a very careful cache invalidation.
Okay, that sounds hard.
Yeah.
One of the two hard problems. Okay, Stu, I think, has a question.
Yeah, I actually just wanted to reiterate something that you said in there quickly, but it was also the subject of my talk. I do think that there's something that tooling developers can do, which is make it easier to make small modules, because within a particular compilation run, there's a lot of hard work that could potentially happen there, and maybe magic will happen, and we'll get parallelism within a run. But people can already achieve parallelism across modules, and so the easier build tools, all of the build tools, make it to make small modules, make and maintain small modules, the more parallelism is available for free. Just to reiterate what you were saying.
Well, I would reiterate again, because that's been my experience, and if anyone knows the sort of things I publish or try to publish, they are generally very small, and when I'm composing several of them together, I can run 4 or 5 compiles in parallel, and I get a result. I'm compiling many more lines per second because I'm using all the cores at the same time. So that's been my experience as well. Yeah, Piotr.
One more thing which I want to say is that one possible thing which maybe could be or should be done is also again lowering the entry bar for doing that kind of changes in the existing solution. So in the ScalaSphere right now, if you will try, we are talking about parallelizing typer, but parallelizing event parser right now, parser is short phrase, but event parallelizing parser right now, it uses so many global state that it's like when you are looking at this code, you are thinking why. It doesn't. In some places, maybe it was like logical decision because it make like error handling easier and so on. I get that. In some places, it just like because it was easier probably, and no one was maybe thinking about really running this fully parallel at the point of writing. But like looking into that and trying to reduce this shared state, before we will try to even parallelize typer and all other phases, just trying to look into what here we can just make simpler and easier. It would be like maybe not speeding up anything, but would be enabling many people to look into that easier, because for someone who don't know the ScalaSphere right now, so let's say we have some contributor to open source, he did some pull requests to various libraries already, and he's thinking, okay, I will do something for the ScalaSphere, I will make it faster. And he is trying to do something. Probably the barrier is very high right now. And for the different compilers like Scala Reasonable Compiler and so on, the reality is that for many big companies, it probably won't be a viable alternative until they will have support for many things, like because during the years probably someone is using macro, someone is using compiler plugin, someone is using some exotic features of the language, and many of these solutions were trying to just prove that something is possible, but are cutting edges here and there. And no one can guarantee that when we will try to add these edges to the solutions, it won't get into very similar state as we have right now with ScalaSphere, or even that these edges will be possible or someone will be willing to add them. So I think for the biggest players, it could be sometimes not an option to really look at these solutions in terms of like 2, 3, 4 years ahead of now as viable alternatives. So I think looking into what we can do with the ScalaSphere to make it easier to, to make for people to look into that and even do small improvements. I think it would be also unblocking some potential which we still have here.
Okay, so you believe there is more. Olaf, I'm gonna. Can
I comment?
I think do we have time for one more question after Olaf has?
Can I comment on 2 things?
Yeah, I was gonna. Can I please, because I was meaning to
go ahead.
answer Christo's questions, and it.
Go.
I have a slightly different angle on this. I think what a breakthrough in improving compilation times for people writing Scala today I think a lot of people can immediately today reap huge benefits by just understanding better where macros are producing large amounts of code, understanding the large files that we are tweaking just one part of it, but you have a very large code blocks that are in the same source file. And I think improved tooling in giving these insights to developers as they're developing is something that is a reap. And I think what Jorge has been working on, ScalaSphere profiling work, which I'm still waiting for you to publish, that can give you heat maps over the code to show like, hey, wait, this is really, you're producing a lot of code through this macro. You might want to move that into a separate module because you almost never change this, but you're really working a lot in this complicated loop here. So try to keep that independent. And I think the benefits that people can have on a code base today with no improvements whatsoever in the compiler is easily can be 2-3x, especially for that tight edit run workflow. That could be 5 seconds instead of 20.
Jorge, did you want to add to that?
Just wanted to say that there are many ways to profile, and I think there are lots of times we are being inefficient just because we are relying a lot on macros and generic derivation. And yeah, the work that I've been doing on ScalaSphere profiling addresses that. And I'd like to publish it soon, but right now I have so many things I'm working on, right, that I don't have the time to publish.
Oh, come on, are you still sleeping?
All the results and everything.
Could
but
you just...
I have very nice results and interesting data.
Could you very briefly summarize in one sentence what it is you are doing with profiling? Because I think a lot of people don't know.
So what I've been doing is I've been improving the ScalaSphere statistics support so that we can know better what ScalaSphere is doing under the hood. And I've been trying to find metrics to measure and reason about code generation and macro expansion and how that interacts with implicit search. So there is a loophole between implicit search and macro expansion, especially when you look for an implicit that is synthesized by a macro, and that can be recursive. So there are lots of things in the ecosystem that rely on this very feature, and we don't realize that it's killing our compile times. And I think it's important that we do.
I've heard pathological stories of compile times for compiling, tiny blocks of code, and then they use Magnolia instead of Shapeless. And well, Scala compiler wasn't slow after all. You were just doing Fibonacci on the type level. So
yeah, Jorge, would you
I think I have the record of the slowest project to compile. It's 8 lines a second. I will show it when I publish the results in a ScalaSphere profiling. But yeah.
Thank you. Jorge, would you just pass the microphone 2 rows back to Yifan? And you have a question, Yifan?
Yeah, I have a question. So I think you guys were all at the keynote. What are your thoughts on furry?
Do you mean today's or yesterday's keynote?
Yeah, today's keynote.
You mean my keynote?
Mm-hmm.
Okay.
Be careful when you answer.
So the question is...
Okay, you're not allowed to answer this.
Okay. So, Shane, like, would you like me to leave the room?
Careful.
I know nothing about build tools. I think I specifically said don't ask me about build tools. I really like that there's experimentation going on in this space. I mean, things like, people mentioned SBT, and there's some unhappiness, and Pants, Bazel, whatever tool you use, it could be improved, right? And that's what we're all doing. We're trying to make better software. We're trying to improve. And so I like that someone is doing incremental improvement. The things that's being done on Pants engine, the things Andy's doing on Bazel, but I also like that someone is going out there and saying, well, what about non-incremental improvement? Let's be crazy. And I think John is the right person to try something crazy.
I would, before we go to Mikhail, yeah, I probably am the right person in that I do seem to have a different setup on many things in my, not just on my laptop, but in my life in general, I think, to many people. So crazy experimentation, which maybe I can sort of make useful for other people as well, not just me. But anyway, sort of carry on. I'm enjoying this.
All right. So I got sort of ashamed after the suggestion that all of us guys have been at the keynote, because I unfortunately was not.
But feel free to share your opinion anyway.
Yeah. All right. As we usually do. I think that it is a good thing that we have now an ecosystem that evolves so quickly and produces so much variety of different approaches that we can actually try and see if a particular approach works best for your situation. And I think just the concept of introducing the source-based dependencies, which were not really a thing before, is a good thing to try.
Okay. Thank you, Olaf.
I missed the keynote.
We'll talk about it tomorrow. Guillaume.
Don't have anything to add.
Okay. Thank you.
I also was not on the keynote, but I have, but I have one comment about that. So I think knowing your other libraries, I think you could be right person for that for one particular reason. I think what SBT sometimes is missing is that it's a very powerful tool, but it's sometimes missing that one idea that simple things should be made really easy, and hard tools should be made possible. And when we are talking all here on the conference and so on, then there are some things which are taken for granted or for obvious, or which are easy if you are working with something every day, or if you really have the expertise with it. So if you are working with SBT every day, then probably it could be a great tool because you know all the stuff. You have the whole mental model how it works, and you know possibly all the quirks and other stuff. But if someone is just doing so, let's say newcomer to the Scala who want to just build something bigger than 2 files project.
Like a two-phase compilation.
Yeah, and I heard so many times that people are just copying the past projects SBT files because they cannot understand what's going on. So today discussion, it was one of our colleagues who was saying, I have this one big project for SBT, and whenever I'm starting a new project, I'm just adding sub-project for this project, so I don't need to configure it again. So I have one big project right now. We have a few dozen of the projects just to not deal with the pain of setting it up again in SBT. So I think this says something, and I think knowing other libraries that you may be the right person to make it really simpler. I think for these people who who really are not dealing with the tooling and with the build tools every day, and I think there is more of them which we think there are, because we are like we have this blind spot because we are all here. We are all working with the developer tooling, or many of us, but it's not like a whole world, and it's easy to miss that sometimes.
Thank you, and thank you for the flattering question. So I think we're probably out of time for questions. Yeah, I'm getting a nod.